Hey everybody, welcome back. I want to make a video on how to name a chemical formula. And when you first start school, there's so much stuff we throw at you. And one of them, we get to writing chemical formulas, we talk about the atom, and now we're going to talk about how do I name this formula? Well, for most formulas, it's actually really straightforward, especially when we're talking about ionic compounds. Covalent compounds have a different rule. So really, when I'm talking about naming chemical formulas, I'm really talking about ionic formulas right now. And there's a really quick way to tell whether something's ionic or not. You basically look at the starting ingredient, and this is a chemical formula that we'll talk about in a minute. And in general, and this is a very works, let's say 90% of the time in chemistry. I'm sure I hate to use exact statistics, but anyways, if the first element in the formula is a metal, it's going to be an ionic formula. Okay, just as an example, if the first element in the formula, or if almost all the elements in the formula are nonmetals, as in um, carbon dioxide, then it will be in a covalent formula. And we'll talk about how to name those later. Okay, so here we go. We have a chemical formula. We've written it. We know how to write it. And here's how we name it. Basically, it's really, really straightforward. We just say the name of the first element, which happens to be calcium. So this is going to be calcium. And if you're starting with a radical, it's even easier. You just say the name of the radical. So this radical for NO3 minus 1 is nitrate. So I'm just going to say calcium nitrate. And that's it. That's how you name something that starts with a metal or may have a radical in it. Even if you had a situation like we did last time with ammonium nitrate, you just say what it is. Now, it works a little bit differently if you end with an element, and I want to give you an example. Okay, so down here we have a compound, very simple compound. It has a +2 ion and a -2 ion. And what do I call this? Well, just like we did over here, we start the naming process by just saying the name of the first element, which happens to be calcium. Now, if the compound happens to end with an element, in this case oxygen, and keep in mind that you could have the exact same type of thing if you had a formula like this. Ca, and instead of a -2, if I had a -1 ion here, this means I have two -1 ions. We start with the first element, and the last element obviously, if you look on the periodic table, this is oxygen. What we do is we change the last three letters of the word, and we add in the letters, substitute in the letters instead, I, D, E. So for this chemical formula, we would substitute the words IDE in for oxygen, so that become calcium oxide. And for this chemical formula, it will be, let me pause. For this chemical formula, it's going to be calcium and then the name of this element. Don't worry about the two here. The two is kind of understood. But when you're naming it, you just say calcium chloride. See if I can spell chloride. Yes, I can. So calcium oxide and calcium chloride. We're chopping off the last couple letters of the name, and we're adding in IDE. And that's it. That's how we name chemical formulas. Okay, so I'm going to just kind of pause right there. I'm going to draw a red line, which means pause. So just kind of take this into account. This kind of bothers people. How do I know this is calcium chloride here? Well, there's only one type of calcium chloride in the universe, and that's this, with this particular formula. So I don't have to say anything in the name about the two. I want to give you a quick example where we do. All right, well, let's just wrap this up. If you have something, the first ion is always, if you say the name of the first ion, which happens to be calcium, then we say the name of the radical if you're dealing with a radical. For a chemical formula that ends with an element, and not a radical, we change the last three letters to IDE and it becomes oxide and chloride. All right. An element that ended with F would be fluoride. An element ended that with Br would be bromide. An element that ended with iodine would be iodide, and so on. All right, and that's kind of the general pattern in the periodic table. Let's do a little bit more difficult example. Okay, So how about this? I'm going to write down 3 chemical formulas, and I'm going to pause so I can write the formulas down. Okay, this is sure to mess with your brains. Um, what I have here is a situation where I start with a metal and I end with a single nonmetal, a single type. I'm not ending, I'm very specific, I'm not ending with a radical for any one of these. Okay? Um, so what do I call this? Well, this is iron and this is oxygen. We guys know that we chop off the last 3 letters and we call this oxide. So I'm going to write the name for this. Okay, so this formula is iron and oxygen. It's iron oxide. Well, what about this formula? Well, this formula is iron and it has oxygen, so it's oxide. I don't think I like where this is going. And this formula has iron and this has, oh, so what gives here? I think you can kind of see the problem we're having. I have 3 completely different chemical formulas, and they all are formulas that actually exist in nature, but they all have the name iron oxide. That's a problem. We have to have a way of differentiating. If you don't like the word differentiating, you could say isolating or separating. We have to be able to make these 3 formulas distinct somehow. And it turns out this goes back to something we haven't talked about yet. Now, if you look at the periodic table, these are the very specific compounds that form, I'm sorry, not compounds, these are the specific charges it forms with these elements. Did you notice anything we left out of the periodic table? Yeah, we left out everything here. And the elements in the middle are called transition elements. Let me pause and write that down. Okay, I started writing it out, but I just decided it'd be better to type it. Everything in between groups 3 and group 12 are what we call transition metals. So you want to really stick with this word here, transition, to help you with the meaning. This means they don't form the exact same charge. Iron, which is the element right here in the middle, iron, Fe, can actually form a +1, a +2, and a +3 charge. And that's actually what we've got going on here. This iron is a +1, this iron is a +2, this iron is a +3. Okay? So the way we go about identifying these things with transition metals is, well, it's a little bit more difficult. When I actually want to name this, because transition metals don't obey the same rules, I have to add something in with the name, and I'm just going to make this a different color so it stands out. We have to add a parentheses in here. And at each one of these names, I'm going to add a parentheses. That one doesn't look very good. There we go, that's a better parentheses. And all we do is we say, okay, if this is iron with a +1 charge, I have to actually say so here. Otherwise, I won't know which one is which. And the way we do that is we use a Roman numeral. And we use the Roman numeral 1. So the way we would say this chemical formula is iron 1 oxide. And if we do that, then I know that this chemical formula means exactly this. It cannot mean any other chemical formula than this. This one, because it's a +2, I'll say this is iron 2 oxide. And this chemical, because it's a +3, this is iron 3 oxide. Iron 3 oxide is only represented by this particular chemical formula and no other. So we'll never be able to confuse iron 3 oxide from iron 1 oxide. Now this naming system was what's called the stock system, and this is something we're going to get into. You may notice, like, how did I know that Fe2O was a +1 charge? Well, we're going to have to kind of back calculate, and that's a subject for a different lesson. Anyway, so I just want to show you how we name compounds. All right, so take a look at this video. The one that'll probably be the most confusing for you is this, and we are going to kind of come back to this naming system again and again, but just to be aware, anytime you have any element that's in between group 3 and group 12, those elements will have to have some type of Roman numeral in their name because they don't always have the same charge. Okay? All right, that's it for now. See ya.